Hi, I'm Tim Schaff, CK Supply's welding specialist. Oxy-fuel brazing with CK Supply's Blue Flame Plus is what we are here to discuss today, and specifically the differences that exist when transitioning from acetylene. It's important to understand that the intent of this video is to properly demonstrate brazing techniques of Blue Flame Plus. Remember, there are many dangers associated with using the oxy-fuel process, and although this video will discuss some of those dangers, it is not intended to be a comprehensive safety training video. Additional safety-related information is available through the following sources: Victor Cutting Equipment, Chemtane Energy, the American Welding Society, Occupational Safety and Health Organization, ANSI Standard Z49.1, Safety in Welding and Cutting, available from the American Welding Society. Many people have heard this term before, but what is an alternative fuel gas? Alternative fuel gases are those that differ in chemical composition when compared to acetylene. These gases are utilized for soldering, brazing, heating, and cutting applications. It's important to note that welding is not recommended with alternative fuel gases due to the fact that they lack the ability to produce the necessary amount of CO2 gas, which is required to properly protect the weld. Examples of alternative fuel gases are natural gas, propane, propylene, as well as proprietary gas blends such as Blue Flame Plus. What is Blue Flame Plus? Blue Flame Plus is a propane-based cutting fuel that is designed to provide greater levels of safety, economic value, and performance when compared to acetylene. Alternative fuel gas cylinders, including those used for Blue Flame Plus, vary in construction from acetylene cylinders. For example, the inside of an acetylene cylinder is filled entirely with a porous filler material. The filler material is then saturated with liquid acetone. This allows the acetylene to be pressurized safely in the cylinder. Alternative fuel gases do not exhibit the same pressure limitations as acetylene. Therefore, the gas can be stored in a hollow cylinder. When using acetylene, liquid acetone can be withdrawn from the cylinder, which can cause damage to the equipment, thus creating a potentially dangerous situation. To avoid this condition, it is required to limit the withdrawal rate to 1/7 of the cylinder volume per hour. Blue Flame Plus does not share the same withdrawal rate restrictions as acetylene. This is beneficial for certain high-volume applications. When comparing the performance between Blue Flame Plus and acetylene, a Blue Flame Plus cylinder can do as much as 5 times the work than an acetylene cylinder of the same size. It is also important to understand that safety procedures remain the same for all oxy-fuel processes, regardless of fuel type used. Let's quickly review some key safety procedures that you will want to follow each time you set up and use oxy-fuel equipment. Always consult with the manufacturer's recommendations for your specific equipment before attempting to install or operate. Inspect the cylinder valve threads and regulator for any dirt, oils, grease, and damage to the seating surfaces. Do not use if any are present. Before installing the regulator, always position yourself on the opposing side of the valve opening on the cylinder and slowly open the valve for a moment to clear any dirt and debris. Use grade T hose, as this is the only recommended grade to use with alternative fuel gases. Do not use grade R and RM hoses recommended for acetylene, as they have the potential to allow liquefied gas to permeate through the gas hose. It is strongly recommended that you install reverse flow check valves and flashback arresters and maintain these safety devices to the manufacturer's recommendations. When using combination style torches, always inspect the O-rings and mating surfaces before using. Check the system for leaks using products specifically designed for use with oxy-fuel equipment. Before lighting the torch, always purge each hose independently for a minimum of 3 to 5 seconds to remove any mixed gases that may have entered the system. Before we begin discussing how to braze, it's important to understand some differences that exist between acetylene and alternative fuel gases such as Blue Flame Plus. Alternative fuel gases burn at a different velocity than acetylene. Because of this, many manufacturers have specifically engineered their nozzles and tips to match the unique burning characteristics of each fuel gas. Consult your manufacturer for a list of specifically designed brazing tips for alternative fuels. When using Blue Flame Plus, the heat generated from combustion is released in the secondary flame, not the primary flame from which acetylene is released. This may require the operator to modify techniques by using a greater standoff distance than what is required for acetylene. Faster preheating and a broader, less concentrated heat pattern might also be noticed. These differences will require a certain level of technique modification from the operator and should be expected when transitioning from acetylene. Applications can vary greatly. Additional experimentation with operator technique as well as brazing tip selection might be required to optimize your brazing operation. Earlier, we discussed that alternative fuel gases like Blue Flame Plus have a slower burning velocity than acetylene. This can create certain unexpected challenges when it comes to lighting the torch, especially for cutting and heating applications. However, lighting procedures used for brazing have only minor modifications from acetylene, and shutdown procedures will remain the same. Remember, always consult your manufacturer's recommendations for lighting and shutdown procedures. When opening the cylinder valve, always stand on the opposite side of the valve and regulator. Make certain the adjustment knob or screw is completely backed out on the regulator before opening the cylinder valve. Next, slowly open the fuel gas valve on the cylinder 3/4 to 1 turn, and slowly open the oxygen valve completely. Always purge the system before attempting to light the torch. Adjust the regulator to the equipment manufacturer's recommended pressure settings for the brazing tip used. Turn the fuel valve 1/4 turn and light the torch. At this step, it is important to make certain that you limit your fuel volume to keep the flame burning at the tip. If too much volume of fuel is allowed, this will tend to extinguish the flame once oxygen is supplied. Next, slowly turn on the oxygen preheat valve 1/4 to 1/2 turn. Making small individual adjustments to the fuel and oxygen gas valves, then slowly walk up the flame until it reaches the tip and a neutral flame is achieved. When shutting down the torch, start by slowly walking down the flame. This is accomplished by making small individual adjustments to the fuel and oxygen gas valves. When using Victor cutting equipment, always complete the shutdown procedures by turning off the oxygen valve first on the torch, followed by the fuel gas valve. Next, turn off both the oxygen and fuel gas valves on the cylinder. Now, purge the gas out of the system. This is accomplished by opening either the oxygen or fuel gas valve on the torch and allowing the pressure on the regulator to drop to 0. When finished, always make certain that the adjustment knob or screw is fully released. As previously mentioned, it is our recommendation that you consult with the manufacturer of your equipment to determine the proper brazing tip and pressure setting recommendations. Pre-cleaning and surface preparation of the joint remains unchanged regardless of the fuel type used. Remember that selection of the brazing alloy depends upon the metal, the joint clearance, and brazing procedures. When brazing copper, first heat the tubing. This will draw the heat inside the joint. Make certain to continue moving the torch to adequately heat both the copper and the coupling. Notice with Blue Flame Plus how the flame wraps around the tubing and is not concentrated to one area. Care should also be taken to avoid overheating the joint. Apply filler metal only when both pieces are up to brazing temperature. As the alloy melts, watch for it to wet into the joint. At this time, it may be necessary to add filler metal to other areas of the joint to complete. In certain applications, it may be necessary to purge the inside of the pipe with nitrogen or other inert gases to avoid oxidation inside the tubing. Brazing copper to steel requires additional attention to the heating technique. Keep in mind that steel does not conduct heat as efficiently as copper. Heating techniques are also affected by the material thickness variations between the copper and steel. Your procedure may vary from those shown here due to application differences. Avoid overheating the joint and apply the filler material only when both pieces are up to brazing temperature. Watch for the filler material to wet into the joint and add the filler material to other areas of the joint to complete. In summary, always follow your equipment manufacturer's recommendation for installation and operation procedures. Always inspect the cylinder valve, regulator, hose fittings, and torch connections for any dirt, grease, oils, or damage that may be present. And don't attempt to use equipment until it has been checked and repaired by a qualified technician. Always purge the system before attempting to light the torch to clear any mixed gases that may have entered the system. Remember, alternative fuel gases carry the heat in the secondary flame, not the primary flame like acetylene. This will require modification to your brazing technique. Thanks for watching, and for additional information, please contact the following: Victor Cutting Equipment, Chemtane Energy, the American Welding Society, Occupational Safety and Health Organization, ANSI Standard Z49.1, Safety in Welding and Cutting, available from the American Welding Society.